Wow, oh wow. Hey guys, welcome to SkyTour livestream for June 15th, 2022. It is I, Marc D'Antonio, and as always, I am here with Daryl Mason. Hey Daryl, how you doing?
Hello, Mark. I'm good. You? Hi, everybody.
Just doing fine, thank you. You know, we got about an hour and a half or so before the, maybe an hour before the moon comes up. So I want to try and take advantage of that. About an hour and was an hour and a half, isn't it? About just an hour and a half, I think.
9:38 Arizona time,
Yeah.
I believe.
Yeah. So we're gonna just check some things out. As you can see up above here, it's not quite dark, you know, but we're still gonna go for it. We're still gonna check out a few things. Meanwhile, what I'm gonna do is I'm going to take us up to the star Spica. This seems to be my go-to star for the time being because it's a bright star and it'll be visible. So I'm going to move the telescope. You'll see it moving up overhead right there. And then we're going to center Spica in the view here. Okay, there we go. And now we'll bring up our field of view. This is our field of view here. And it's 4 full moons across by 3 full moons tall. And as we zoom out a little bit, you'll see the crosshair for the STLS telescope. And we're going to move to the east a little bit. Alright. And by moving to the east, we moved to the east a lot of bit there. I'm going to move it back. There we go. Alright, and now what we'll do is pop us back a little bit and change our speed down to a little bit slower. And you know what? I gotta say, Starlink has been working beautifully. We haven't had any problems with it. Let's hope it stays that way. Alright, and here we go. Now we're gonna move in here. Watch the crosshair on the screen there, and you can see that it's moving closer to Spica. And watch for it on this screen. This is our main view here, and we're gonna check that it's there. I may have to increase the size or the exposure time a little bit, just to, or sensitivity. So let's go up. Now let's go to the south a little bit, and the telescope will come down in elevation a little bit. And now Spica should be in the field, so I'm going to come in here now. And I don't see it, but I am also at a fraction of a millisecond in time. Let's go up to, say, 50 milliseconds. And there's Spica right there. Perfect. So we're good. And we will just take it down a notch. Pull it down into here a little bit. That's the wrong way. The other notch. There we go. Let's bring up our crosshairs so we can center it all in there. Okay, here we go. Moving the telescope up. By the way, I want to welcome everybody. It's good to see you guys. And I see Doc from Wyoming is with us. Nice to see you, Doc, on a hot S77. That's Bonnie from Colorado. She's here. Viralicia Campos from Brazil is here. C&D Boy from Canada is here. How you doing, man? And we have Daisy and Zoe Amethyst. And, of course, Daryl is all over the chat already, which is fantastic. He's got his pulse on everything. And then we have Shifa Heyoka Queen 6 is with us. How you doing, man? And Carmen. How are you, Carmen? Nice to see you. And it's good to have you guys with us. And Tim F is with us. What's going on, brother? It's good to see you. So we're gonna have some fun tonight. We're gonna have a little time with the sky getting a little bit dark. I'm gonna center this up, and then we're going to check coordinates, make sure that we are pretty close to where we need to be.
I think Vera left us. Her dog ran off. Yeah.
Uh-oh. Well, hopefully she'll come back. Okay, so there's Spica, pretty well centered. I'm just going to give it a little punch to the east here. A little more. sorry, I meant to the west. My apologies. All right.
I've heard if your dog or your cat runs off, put their food dish outside and an item of your clothing that you've worn, or like a pair of shoes or something that you've worn, and they'll come back to the smell, and it'll help keep them there.
That's pretty cool. Hey, Lewis, the rings are just a little mechanism I use. It's a little crosshair system so that I can do perfect centering of things. I have several options. I have the doubles, I have the reticle, I have the straight lines, and then nothing. So that's that's what we're doing right there. Again, we're trying to keep these 4 full moons across and 3 full moons tall sized field. We're trying to keep everything in proper coordinate system and in synchronization. And so far, all synchronized.
Would you normally sync in Stellarium at 2 at this point?
Yeah, which I did already. I just did that.
Oh.
Yeah. See, here's how it works, guys.
Sure did.
Yeah, the coordinate system here, okay, you can see north, south, east, and west up here. And it's in right ascension, which is the east to west motion, and it's in 24 hours. If you divide 24 hours by 360 degrees, or 360 degrees by 24 hours, you get the degrees per hour, okay? And that tells us how many degrees we go around. In one night is 360 degrees. All right, and so we divide those into hours, all right, and then we have the declination, or the up and down, which is plus 90 and minus 90 for the South Pole, all right. So where our telescope is set up following the latitude and longitude lines, basically, of the Earth. And these blue lines you see here in our planetarium program, these are the latitude and longitude lines of the Earth extended out into space. All right, and that's what this is right here. So that's where we do that. All right, and usually we're up close, so you just see the blue lines, but really we're looking at the entire grid of the entire sky. Okay. All right, so we are actually in pretty good shape with our setup here. You notice that the telescope up here has just gone to infrared. It went from the color mode, which needs a certain threshold of light, into infrared, which says that the light is now fading, and we're gonna be able to start looking at some things. The view of this Spica star here, the view of that star, which is Alpha Virginis, the brightest star in the constellation Virgo, is just for the purpose of trying to get a star in the view for now. And you can see this is how bright it looks if we actually use our what I call our finder mode. And this is a mode where we're actually looking at the sky in 125 millisecond bursts. See that exposure up there? So every 125 milliseconds I've got it set. Normally you go a second, but it's too bright for that. And the gain right now is 200. The gain can be 0 or the gain can be 600. If I drop the gain to 0, you'll see how this actually works. Alright, so now you can see that the star looks a lot dimmer, but I can then really push it further and get it to about the same thing.
I have a question.
Yeah.
I noticed your telescope controller, your keypad down at the lower left,
Yeah.
isn't saying Spica. Is it dialed in?
Oh, you mean
yet?
here?
Yes.
Oh yeah, no, it's all aligned. It only says the star that's going to if I'm doing a high precision slew, where we get the waypoint stars. So we're not doing a waypoint yet. I just drove it directly to where Spica was in this guy over here, our planetarium, and that's where I stopped it. I just drove it in, and it was there because I had previously aligned the scope and got everything. Well, the scope was aligned from the time it started up.
Yeah.
So we're good.
Very good. Just curious.
Hello there, Alanis Brown. How are you? Oh, yes. I know that the moon was a beautiful orangey pink when it rose yesterday. It hasn't risen out here yet in Arizona. It's risen on the East Coast, I think. I have to go check.
It has.
Yeah, but it hasn't risen out there. But it'll be really pretty. Oh yeah, and you can enjoy the music too.
I watched the moonrise here last night, and it was wreathed by a little faint bit of cloud, but it shone right through it. It was really pretty.
Okay. Did you have any moon dogs?
No.
Okay.
Nope. Not enough humidity in the air for stuff like that. And today it was beautifully clear but windy, and that just sucks all the moisture out of the air too. It's just a crystal clear day.
Mm-hmm.
Looks to be a crystal clear night too.
Wow. What are you doing here? You should be out there with your telescope.
Yeah.
Yeah.
I feel bad now.
You're a bad astronomer, right?
I am. Bad astronomer, bad.
Yeah.
But hey, this guy asked me to be on a live stream with him tonight, so I'm here instead.
You know, you got to just put those people in their place who expect you to just, hop to and be there whenever they say. Who do they think they are?
Yeah. Well, that could get even worse. I've been admiring telescopes again.
Oh, that's very good.
Yeah, well, I'm not even using the one I have now, so I want another refractor, darn it.
Yeah, I've one of the scopes we're looking at for a second scope out there is one of these fast refractors, but I actually want a telescope that's going to be fairly high power.
Sure.
So I think that's kind of what we need. Yes, welcome to STLS Galaxy Night. We're going to be looking at a few galaxies tonight, but we're also going to take the time to look at a few clusters here and there. And then once the moon rises in an hour and a half or so, we'll probably stick around for a few more minutes and then call it. But I think we just want to try and find a few things tonight and check the quality of the sky. If it's clear, I always try to run something to try and check the sky quality.
You said before the stream to think of something, and I thought of something. I actually said it, but you had me muted at the time, so you couldn't hear what my answer was.
Okay.
M100.
That's nearby.
Yeah, but we do need to wait for it to get dark.
Yes, that's right. Okay. By the way, I just want to share some news with you, which I think is kind of interesting news. And it could just be a case of mistaken identity, so you know. But one of the things I wanted to mention was that the Chinese announced a discovery with their FAST radio telescope. And the discovery was that they think they've found an extraterrestrial intelligent signal coming from space. And you heard it here first if you haven't heard it yet. However, I will say this. We also thought pulsars were an intelligent signal until they weren't. The first fast radio bursts were thought to be an intelligent signal until they weren't. And then there was a repeating fast radio burst, which looked like it could have been a techno signature, as we call it. But it turned out so far that there's no evidence indicating it was an intelligent signal. So I think that's pretty interesting. So we'll see what happens. The Chinese, by the way, quashed the story as soon as it was announced. They pulled it off of state-run media. And that could have been because a scientist was just too rambunctious and excited and kind of overstepped and said something that wasn't true. It could be that. But we'll
My
see.
sister was the first person I heard the story from when I got up this morning, and she said it reminded her very much of the. There's a popular sci-fi book out there now called The Three Body Problem,
Oh yeah.
written by a Chinese author, and she said she thought it was very reminiscent of the Three Body Problem. I haven't
Okay.
read it, so I don't know myself, but I guess it started in a rather similar way with Chinese detecting a purported radio signal.
Yeah. I honestly, it's going to be a radio signal, folks. That is what we'll see. Some kind of radio signature. We could find industrial pollutants in an atmosphere of an exoplanet using the James Webb Space Telescope. And I was on a show today with Becky Ferreira, who's a science writer, and Becky was talking about life on Europa, and I joined as an astronomer to kind of just listen in and ask her some cool questions, and she knows her stuff. Let's put it that way. So Becky Ferreira, you gotta check her out. She look up the article on Europa because I read it, and she's a really fine author. So I think you should check it out. But life on Europa was an interesting discussion because, there's so many reasons why life could exist and so many reasons why it probably can't. And until we get there, we won't know, or unless we see something as a signature of life. Now, when we're looking at exoplanets, other than in our solar system here, if we go to, say, look at, say, an exoplanet that has what we think is a habitable zone capability or characteristic, then I think what we could find is that we might find that. Hang on, I'm going to do this for you, Becky. Becky Pani. What we might find is that the James Webb would be able to detect a possibility of oxygen in that atmosphere. Excuse me. Hang on, I'm going to get a drink. I'll be right back. It's right here.
One thing I'll say while we wait for Mark, there have been other stories coming up recently about, oh golly, they heard some kind or other
Can't
of a
believe I abandoned my post.
radio signal from
Just for a second.
3 billion light years away. And one thing to keep in mind if you hear about things like that, folks, especially at that kind of a cosmic scale, that is absolutely not any kind of a intelligent signal. That is a natural process happening.
What are you talking about, the fast radio burst?
Yeah, whatever it was in the news here in the last day or two.
Oh, okay.
They heard something, and it was like 3 billion light years away. We hear something from that far away. That is not going to be any sort of an intelligent signal. That's some kind of a natural process at work.
Yeah, probably so. I want to say hi to that Jen dude. I want to say hi to Marianne Rob. Ta-da, how are you? And I want to say hello to Ricardo. What's going on, Ricardo? Good to see you again. Yeah, we're just letting it get a little darker. You can see right up there that it's getting darker and darker. Yeehaw, we're happy about that. And now, we have our telescope set for 125 millisecond exposure. I'm gonna take us to 1 second here and see if that makes, if we can get that. I bet you we can probably do that now. We'll find out. Might be a little bright, and I'll just do an adjustment. Here we go. There we go. There we are. These diagonal lines are an artifact of the system that I'm removing in a few weeks when I go out there. Hey there, Alice. Alice is here with us tonight. Alice play on the word Cooper Pooper. Really cool. Okay. Now that I've got this, we can probably connect our focuser, which I'm doing right now over there. You can see just right over here. There it is. It's all connected. Now let's see if I can go take our focus out a little bit and then bring it in. Measure 100, huh?
Sure.
All right. When we get a chance to do that right after this, I will. All right, let's go here. All right. All right, now we're going to scan in and take care of our focus. We're in the process of auto-focusing the system. I've talked about it before. These stars are stars selected to be focusing tools, and the telescope is auto-focusing. It's changing the focus by set amounts and seeing where it's going to build a curve down here that's going to curve like this in the end. At the bottom of that curve is where the focal point will be, the perfect focus. And when it gets to that point, it's going in increments, but when it gets to the point where it actually finds that spot, it's going to go to the exact lowest spot, whatever that setting is. And we're talking about accuracy to like I think it's a 10,000th of a turn of this little focusing system knob. So there it is. There's that focus spot, and we're at 9. Okay. See that? Best focus already found. Didn't even have to go to 12. There we go. So now we're going to go out of focus and then back into focus to that central spot. Here we go. And boom. This is now perfectly focused. And we can see it when we do this. You'll see that the stars are absolute pinpoints. I love it. All right. There we go. So you can see our beautiful pinpoints. This is the star Spica. It's the brightest star in the constellation of Virgo. And we are going to check out this star, this galaxy here. This is called the Blow Dryer Galaxy, or Measure 100. It's also called the Mirror Galaxy, and not by me. I've always called it Measure 100. But this particular program has a way of having some fun with you, I guess. I don't know. All right, anyway, here we are. We're in here. Let's just go now. It might be dark enough to find it, so we're gonna go here now. Watch the telescope will start moving. I just gave it something to move to, and it says high precision slewing right there. And now it's gonna go to a waypoint star, and it looks like that's gonna be the waypoint star. And you'll see which one it is right over my head here. Which star we going to? Let's find out. It's right up there.
Vendemiatrix? Nope.
No, Denebola. Yeah. So what happens is it's going to move that star right to the dead center, make a final little adjustment, and then it's going to put the galaxy we seek right in that exact spot. We're close to it. So I got my cursor there, and let's see how well it's going to work. Oh, it's going to do a little more centering. There we go. All right, so there it is. Let's see how well it works.
Denebola is the tail of Leo the lion.
You see where my cursor is right there? Let's maximize this and see if we can see Measure 100. It may not be dark enough yet, but it might be here. Might be right there. I can't tell. Not quite dark enough yet. As you can see, you can still see the sky in the observatory up above. So it's going to tease us. But you know, we can try. We can try a... let's try and do a 12-second shot. And see if it can show us anything. We'll do 12 seconds now. Over here on the lower right, you see a progress bar moving. There it goes. I don't see it yet. But it's definitely in there. What's that?
Still a little early.
It is. If anything, this points out to you how difficult it is to see things when you have subtle light pollution in a town or a city. You know? I mean, this is serious light pollution now with the fact that the sun hasn't set yet. It has, but it's just, you know, still got twilight. I'm always rushing things. I always want to rush it. That's okay. So if I maximize this. Yeah, there it is. You can just see it. Right there. Measure 100. Right there. It's a face-on spiral to us. At least it
really
looks like
pretty
it.
one too.
Yes. Hey guys, make sure you give us a thumbs up and subscribe if you haven't yet. You know, yeah, we gotta just check it out. Oh, Marianne, thank you. She says proof is out there. Yeah, I talked to them today. I've got I'm on like 23 episodes or something like that. It's like a pretty good show. Not because I'm in it, but it's a good show because they actually give things a fair view and they don't just say things are UFOs or whatever. All right,
Daisy and Zoe asked about seeing the 5 planets.
Okay.
You have to stay up either very late or get up very early to see them. I came wide awake at 4 o'clock in the morning a couple of days ago. I went ahead and got up and went out and looked, and it was about 4:30 when I looked, and I saw them all except for Mercury. Mercury was up, but it was very low behind some houses over to my east-northeast.
Yeah.
Couldn't see it yet, but saw all the other ones. It was neat to see.
That's cool. We're still waiting for it to get darker. That's why it looks so grainy and nasty. But the galaxy's right there.
And actually, if you had a telescope to look, you can see the 5 classic planets naked eye before sunrise. But if you have a telescope, Neptune and Uranus are both up there in that same line too. If I remember right, Neptune is between Saturn and Jupiter, and Uranus is between Venus and Mars, I think.
Yep. Hey there, hi alpacas. How are you?
All 7 of the planets, all the planets except for Pluto, are up in that quadrant of the sky right now.
Yeah. As you can see, the telescope is aiming straight up. You know what's interesting? I don't know. I keep saying this stuff, but you know what I find interesting is the fact that we can do this at all. I am just beside myself with the ability to bring this public outreach astronomy to people from 2,500 miles away. The telescope is out there in the desert. I'm out in Connecticut, and it's been running beautifully. It has issues from time to time, but then again, telescopes have issues from time to time. But boy, it's just amazing. It's like having a window in the world that you just never see. And the sky's so dark out there that it's just incredible. Incredible. It's awesome. And it's only going to get better, by the way. It's only going to get better. I mentioned this before. I didn't get them yet, but I'm getting a lifting column, at least for this telescope out there. And that's actually a hydraulic pier that's going to go up in the air and bring the telescope up above the walls of the building. Now, it's a well-known thing. That looking toward the horizon with a telescope doesn't really get you much. But because there's a few southern objects we'd like to check out, the sky out there is so clear that looking to the horizon, it won't be the best view, but you'll see more beautiful views than you could in other places where it's higher in the sky. Promise. So we want to get a lifting column that's going to lift our telescope up by about 2 feet. And that'll be one of the things it does when it starts up. It'll just go lift up in the air, and that makes it more subject to the wind, okay, to be fair. And there are nights when we might not lift it if the wind is too much, or we might lift it and then lower it back down. So we'll be able to go up and down depending on the object we're looking at. And that's kind of where we're going. That's going to be the best thing for us. Notice the sky is still got a little brightness here, but it's getting darker. Wow. And this is something else. And there goes a satellite. This one's zipping through. Alright. Let's just get this here.
Astrophoto of the Day had an interesting image a couple of days ago, a day or two ago, of satellites over Australia. And it was an interesting picture, but it wasn't very heartening. I mean, even down there
lots of lines.
Oh yeah, even down in the middle of the outback, I mean, there were just satellites everywhere. And most of them were Starlinks.
Yeah, I believe it.
Not to knock your guy.
No, look it. The reason we see what we see tonight is because of Starlink. I have a Starlink set up out there. We're attached to the Starlink server. It's almost real time, controlling this computer through the network and through the Starlink satellites. Not bad. I did notice an outage where we had an outage for about 20 seconds at one point. Not tonight, but during the day. So that was something that, is not a problem for the daytime, but at night it is. And if we do if I set up our solar telescope out there and put that on a stand and we start doing solar astronomy, well, then we might care about it then. But not right now. Okay.
Doc from Wyoming asked a question. Marc and Daryl, what would be a good portable scope that can be carried and set up in the field? Thanks. And I asked him, what's your budget? Doc,
well, go ahead. You give your offering and I'll offer mine.
$500 to $600. I'm of the belief that aperture is king, and I'll give my usual answer. Portability, it sounds like, is a factor to you, though. Go to Orion Telescopes online. Look at their 6 and their 8-inch Dobsonian telescopes. Used to be you could get the 8-inch easily for the $600, and the prices of telescopes have gone up like everything else. The 6-inch aperture is less aperture than the 8-inch. It may be closer to your budget now, and it will be more easily portable than the 8-inch will. Even the 8-inch is fairly portable. Look at the 6 or 8-inch Dobsonians at Orion, and you might consider getting a couple of extra eyepieces too, of different focal lengths, so you can. That's how you change your magnification, is by changing your eyepiece, by changing the focal length of the eyepiece.
Yeah. Hey there, Dimensional Legend. Welcome. Alright, we're just getting darker out there. Let's give ourselves another 12-second photo to see if we're looking better out there. For this, we'll live stack this as well. And we're going to clear this previous one. It's grainy because it was still light out when we were taking a picture. Now we've cleared the stack, And we're going to come in. Progress bar is almost full. Got our first image. And let's see what we got. Okay, it's not quite there yet, but we're getting there. Not quite there yet. We're okay. Still getting dark. And I'm gonna actually increase to 250 and get rid of this. Alright. So that's where we are. To see the galaxy. And we're going to add a few additional processing tasks to help make it look a little better. This right here is one of them. Then we're going to go into enhancement here, and we're going to actually add a sharpening factor. So now you'll see this is going to look a little different. Okay. And then we're going to zoom in because we can now. And we're at this galaxy because Daryl suggested it. He wanted to see M100, so we're going to look at it. Well, there's M100. Once we see it a little darker, it's going to be better.
Yeah, this is a very pretty spiral telescope. It's a showpiece object.
Yeah, it is.
Face on.
Yeah, beautiful. Okay. So this galaxy here that we're looking at, right, here it is right there, and its distance from us is around 54 million light years, 55 million light years. That means this galaxy's light left about 10 million years after the death of the dinosaurs and made its way to us. That's how old this light is you're seeing right this second. Isn't that incredible? I think that's a pretty impressive thing.
I just set you up to plug your book, Mark.
You did?
Alanis Brown had a question. Do you guys believe there is life outside of our Earth?
Oh, thank you, Alanis. That's a really good question. Yes, absolutely. In fact, the show I was on earlier tonight, we were talking about that very thing. The book I wrote is actually called The Populated Universe, and it's on Amazon everywhere. And what it does is it talks about the fact that life in the universe may very well be the rule and not the exception. And it's based on the fact that we're carbon-based, and that carbon is number 4 in the hierarchy of abundances in the universe. Oxygen is number 3, helium's number 2, and hydrogen is number 1. And hydrogen, oxygen, and carbon work together quite often to make compounds and the stuff that makes life work. So you may want to read the book. It's actually about it's written for lay people. It's not written in language that's going to go over anybody's head, and that's kind of where I live, is trying to make things digestible so people can understand it. Everybody wants to understand stuff, and I think my rule is science is for everybody. So it should be made available to everybody, and it should be understandable by everybody. So that's kind of where I go with that. But check it out. There's several versions available. I have there's a Kindle copy you can get. You can get a black and white paperback that's like a 5x9 or 5x8 or so. And then the 8x10 is full color with a lot of illustrations that I put in, which I think are kind of cool.
Trying to post a link for you. The darn link was too long. Maybe this one will work.
Okay, no worries.
Yeah. The
Okay.
Kindle version fit.
All right. Well, hey, that's okay. Thank you, Daryl. That was kind. Okay. Still waiting for it to get a little darker out there. And you can start to see anyway, you can see these beautiful spiral arms. There they are. Look at them, huh? This is noise that's going to get removed over time. I mean, we've got... You can see how these are going to go away. It's actually not quite dark out there yet. So we're getting a lot of noise in this image. I bet if I clear it right now and we do another one, it's going to come in pretty nice, actually. It'll be noisy at first, and then it's going to get smoother. Let's go see. Alright. Let's do the color correction. And then move over. Move it down a little. There we go. Alright, and now target is Measure 101. It's called M101. It's a face-on, beautiful spiral. And you'll see this title up here on the server where we have all of our images. It's a free server that you're more than free to go and check out and use and download anything you want and use it all you like.
M101.
Did I type M101? I'm sorry, I did, didn't I? I meant to say M100. I couldn't read that. I apologize. Okay. Well, I didn't save it yet, so we're okay. Okay, that's M100 so far. And let me just give you that label. Okay.
I mean, if you want to go to M101, that's fine with me.
I know, 'cause that's another pretty one. All right. All right, let's go back here for a minute. Do this. Okay. And let's drag this down a little bit. All right. You'll notice also that when we take pictures of a galaxy, many times you see another galaxy or more, and we have no shortage of galaxies in this region of the sky. There's one there, there's one there, there's one there. I think there's one up here. And many times these galaxies are interacting with each other as well. You know, so I think that's really fascinating thing that happens with these galaxies, that sometimes they interact with each other. Okay. Let's do this. I keep doing the processing just to push a little bit. And we're going to do a color correction. There we go. Get rid of some of the green. Some of the blue. There we go. That looks better. And we're zoomed in to 75%. So, if we zoom out to fill the frame, this is the whole frame. So that's how small the galaxy is in our field of view. And look at all the other galaxies. 1, 2, okay, 3, 4 over here. I saw it. 4, the main one, of course. And then several others. Really amazing. And this is only a 12-second shot. Normally we're doing longer exposures. So why don't we do that? Let's see if it'll support it. Let's see if we're dark enough for that. We're going to do a 25-second shot now. And in our stack, we're actually going to clear it again. Sometimes longer exposures look better. Okay. So once this comes in, you're saying something?
No, sorry.
Okay. All right. No worries.
Izabela's here. Hi, Izabela.
Izabela. Hi, Izabela. Those of you in the stream know Izabela. She is the one who does our table of contents. She also has some really great questions she's always asking. Very smart lady, that one, and she's from Sofia, Bulgaria.
Tara's here, too.
Tara Diulis, the artist who did our door on the observatory and was also the secretary of the SkyTour live stream organization. Hi, Tara. Izabela says, I think I have the privilege of knowing the craziest astronomers in the world. Well, okay. I think that's a compliment. Let's zoom in on this galaxy. Let's zoom in and see just how many billions of beings we're looking at millions of years away. Look at that.
It's starting to show up better.
Yeah, yeah.
And you can see distortion in the spiral arms now where the galaxy has interacted or is interacting now or then with other galaxies.
Yep.
See, they're spread open a little unevenly.
They are.
The upper spiral arm up at about 12 o'clock, you see how it's got a crook in one arm there at about 11 o'clock.
Right there. Is that another galaxy, or is that a... I think that's another galaxy in here, right?
Yeah.
Might be interacting with this, or maybe it's further distant. I don't know.
I have looked this up before. I'd have to look it up again. I don't remember offhand.
No
But
problem.
it is interacting with at least one of those galaxies.
Yeah. We should look at the supernova tonight.
Sure. Good idea.
We've been tracking a supernova in galaxy NGC 4647, I believe.
Yeah.
And we'll check that out too. We'll get some more of these stacked, and then we will go and check it out. I want to try and do some real work before we actually have to quit because of the moon. So to do that, the best thing to do is to actually get a few of these things under our belt first. But I want to get that. I want to get that supernova as well.
That's a good idea.
It sure is. Alright, let's pull this in a little bit. Look at that beautiful galaxy. And again, like I said, we're zoomed in quite a bit. And PG is here. How are you, Petita? That's Petita. Nice to see you guys. Let's drag this black level back just a little to kind of give us a little more detail in the galaxy. There we go. And maybe we can push it a little bit. There we go. So yeah, look at that. That's beautiful. There's another galaxy here. Another galaxy here. Might be one there too. And then we have one here. We have one here. Our field goes on and on, as you can see. We've got one here. Right here. Got one right here. Got them everywhere. We have a satellite right there. We have another one right here. Another galaxy right there. In every one of these, you know, we're looking at 100 billion to a trillion stars, depending on which galaxies we're looking at. So you know these galaxies are just the most incredible places, and would certainly have a huge number of potential planets in them, and stars with planets in them.
Mark, can we go to Stellarium for a moment?
Sure. Let's bring this back up here first. There we go. Okay. Off to our planetarium. Sure, what do you want to look at?
And can you step out a little bit?
I might be able to.
I was wanting to see where we are.
Well, the Virgo galaxy's right here.
Yeah, okay.
We're just north of Marcarian's. We're north of Marcarian's chain.
Oh, that might be another target too when you're done with M100. But we're still, you know, we're close to the center of the Virgo cluster.
Yeah, I want to do 4647 though and check on the supernova.
It's close by also. I think it's just off to the left a little bit.
Yeah, that's why I'm gonna check that out after this guy right here that we're doing. And then we'll explore a few of these things before we head off. I mean, we can search for M60 too, because M60 is in the same field as 4647.
Yeah, it's right next to it.
There's a satellite right there. And, okay, let's go check this out, see where we are. We have 16 stacked here. Let's see how it looks. Oh yeah, see, we got some detail in there. Let's color balance. Okay, got a little color balance right there. Right, a little another color balance. Here we go. Okay, we're gonna pause this right now, and I've got it set to M100 up there, and we're gonna save this. And right now, this is going out to our server. So these files are now leaving our server. I'm sorry, leaving our observatory and heading up to the server, where they will be available to you within just a few seconds. Now we'll save this exactly as seen. All right. All right, good.
That is such a pretty galaxy.
It is. Measure 100.
And you can see enough now that if you look at about 9 o'clock to the center of the galaxy on that same spiral arm, there's like a fluff sticking out the side right at 9 o'clock.
This here, or this? What, this?
That on the outer arm.
Yeah,
well, actually, both of
right?
them. That the inner spiral arm.
See, this has a crook in it right there.
Yeah, the inner spiral arm is kicked out that way, and then there's that little puff piece sticking off the side, also at 9 o'clock on the outer arm, kind of aimed toward that galaxy to the left.
Yeah, let's see if we can just do. Let me actually add a filter to this that might soften that noise a bit. Okay, that looks like it helped a little bit. Okay, nice. Well, Ricardo, I'm glad you like it. All right, so let's save this again.
Very nice.
And save it exactly as seen again. So now 2 pictures will show up out there, and that's fine. Hey, David Yelich, how are you? Where can I get the software and it is connected to a telescope? Yes, if you have a if you have a telescope, David, it's likely, if it's one of the more modern telescopes, that you can get the software to control it. And the software to control it could be this program right here called Stellarium, which is extremely expensive. It's going to cost you $0. Okay, it's a very, very wonderful program, and it'll connect to your telescope. And we're connected now, and in our telescope, see where that little plus sign is? That plus, that's our field of view right there, or actually our connection. All right, so that's where we are. All right. And it represents the field of view. This box I put in, it's a field of view. All right, so anyway, that said, let's now go in and let's clear this because we saved it already. And we'll get out of it. And now let's go look at a supernova. All right, that occurred. This supernova is really something, and it is called NGC. It's in the galaxy NGC 4647, I believe. Yeah, there it is, right there. You know, it's not far. And now we're gonna go over there now. Here we go.
Like I said, just a little bit to the left.
You got it.
Just over on the other side of M87 and Markarian's chain.
That's right. Okay, now we're getting a star here. That's what I call our waypoint star. Let's see which one it is. I didn't turn on my computer in the telescope at the moment. It's just, I let it go off.
Vendemiatrix.
Right. It's Vendemiatrix, yeah. And from there, it's going to go to that galaxy. So it's going to zip off that way. Alright, here we are. And away we go. Alright. And now, centered in the middle here, you're going to see a very bright, well, satellite going through. This bright galaxy right here is called Measure 60. And right up here is a fainter but equally beautiful galaxy called NGC 4647. NGC 4647 stands for New General Catalog 4647. Let's go to 75%. Yeah, and what we noticed is this object. We're going to zoom in even more. Now I'm doing a live view here for at 1 second intervals, but let's just go and let's go in actually a little more, shall we? I want to show you. All right, I think we're having one of our little StarNet or Starlink outages right now. Okay, we'll just wait a sec. Yeah, okay. We had a little outage right there. That was a little bit of a Starlink outage. No big deal. It's back. Just gotta wait a few seconds. Doesn't always happen, so we're fine. Okay, now.
How long did it last?
It lasted about 10 seconds. So there it is. Now, if we zoom in some more and doing this live view here. Okay, now the live view is obviously rough because we haven't done an exposure here. Hey, neutrino. But now, if you notice that little dot right there, that's a supernova in this galaxy that we had picked up last time we were looking. And what we're going to do now is we're going to do a 15-second exposure of this and do a live stack of it so we can see it. Okay. And you're going to like this, I think. So let's go in here, go back to our histogram page and do this, and then color correct. All right, this is the supernova right there, and this is galaxy NGC 4647. This is galaxy Measure 60. Okay, they only look like they're close together. They're not like this close in space. 4647 is likely further away. I think it is. I'd have to check again.
They are interacting,
but they're not. This one is further away, I believe. I don't think. I think Measure 60 is closer to us.
I think you're right. Yeah, I've looked this up before. They the article said they've just recently, and cosmologically speaking, have begun interacting with each other.
And what's interesting about that is that this interaction process could have sparked star formation in this galaxy, and it could have sparked, in fact, spiral arms to form in a galaxy. That's not unheard of. It's actually quite common that spiral arms are formed by galactic interactions with each other, which is really kind of cool. Okay. So here now you can see this a little better. Obviously, again, we're in the area where there's lots and lots of galaxies. There's plenty of them. There's one here, one there, one there. And then, of course, these two. And there is that supernova. Check it out. Let's zoom in on that, shall we?
Yep. So we noted last time it had turned kind of an orange color.
Yeah, and still orange.
Still is. Do you think it's dimmer than the last time we looked?
Hard to tell. I don't know if there's that much of a difference. But the very first time we looked at this was bright blue.
Yeah.
And the reason is because when a supernova first pops, a star first blows up, it's extremely hot and extremely energetic. So the temperatures released are going to be very, very high, and a lot of the energy will get released in the ultraviolet and the gamma ray region, all in the far end of the blue spectrum, all the way beyond what you can see. But you will see blue light. And so this was actually a very blue object when we first started imaging it. And now it's red, which means that the temperature has been dropping as that supernova has been expanding, that remnant has been expanding.
Yeah.
Pretty cool. Now I'm going to come back in here and just do one thing. Go ahead.
If I remember correctly, we first looked at this object early April, I believe. So we're going on 2 months now since the supernova happened. I believe it happened late March. So it's I'm kind of surprised it hasn't faded yet.
Well, I mean,
maybe it started. I mean, like you said, it's changed color, so it is cooling off.
Yeah, and it's definitely expanding. Tara says, I like it, very cool. The thing that's interesting about the supernova is that, if there's other interactions as it's expanding, then that could change the characteristics of the expansion of the debris. So they could perhaps change brightness, change frequencies of light that we might be seeing based on what they're interacting with, what they're hitting as they're expanding. That's possible. But for the most part, it's got a general trend toward cooling. And so this general trend is what we're seeing here. It used to be bright blue, and blue is the hottest. When you have something that's very, very hot, the hottest it could be, it's going to be blue. And the energy it gives off is dependent on its temperature. So the wavelength of being blue is going to be very, very hot. Then when you see red, it means it's cooling down to the into the 5,000 to 3,000 Kelvin range. Blue, you're talking about 40,000 Kelvin or above, and it's really, really hot. Okay, let me...
Yeah, if you look at 4647, I see a faint dark lane between the nucleus and the supernova. Right there,
yep. Can't miss it. It looks really pretty.
Yep, 4647 is a spiral. If I remember correctly, Messier 60 is elliptical.
Elliptical, yeah. That's right. This sort of enhances and shows you that spiral arms, dark lane in here. Just a little. That's cool. Alright, so let's do this here again.
And I forget, that helps it stand out some.
Yep.
Wasn't this type 1A supernova?
Yes, it was actually. A type 1A differs from a type 2. There's a variety of different types, but primarily it's either a core collapse supernova or it's a binary white dwarf star a white dwarf and another star system supernova. And this is what this one was. Type 1A was where you have a you have two stars orbiting each other, okay, and they're both normal stars. One of them evolves to a red giant and then shrinks down to a white dwarf after it stops fusing. All right. Meanwhile, this other star going around it is still orbiting it, and then it's going to go to its red giant phase. And when it does, if depending on how close they are, some of that material on that red giant can bleed onto the white dwarf. That's a bad thing, because white dwarfs don't want to be more massive than 1.44 solar masses. If you go past that, then you can get runaway fusion on the surface of the white dwarf, and that could cause the star to be completely disrupted or destroyed in what we see here, type 1A supernova. Okay. Type 2 supernovas where a star, a massive star, 10, 20, 30 times the mass of the sun, runs out of its nuclear fuels, and the entire core of the star collapses. And when that happens, that is a shock wave. It gets sent through the entire star. It collapses, hits the core of the star, and goes outward. Meanwhile, all the rest of the stuff is coming in, and all this other stuff's going out, and it just rips the star to pieces again. That's a core collapse supernova. And it's during those processes that we actually get more elements in our periodic table. The ones that fill the periodic table come from a supernova explosion. The 1A will produce elements, and so will the core collapse supernova produce elements. So we get them from everywhere. Well, that's beautiful. Look at that.
Yeah.
Wow.
Mark, could you excuse me for a moment, please?
Yeah, go ahead.
Be right back.
Okay. I'm going to drop the green just a little. Okay. That's a little better. Let's see if I can drop the red here. Yeah, that's better. That's good. Okay. Very nice. Okay, so now what we'll do is we've got 32 of these stacked. We're going to pause this supernova, and I'm going to come up here and change its name to NGC 4647 space SN for supernova. Okay, and now we can save it. Alright, and it saves our FITS file, which is an astronomical format. You can get free viewers to look at that, but you don't have to, okay, because we're going to also save it exactly as seen. So you're going to get this just like you see it, and you can download your very own supernova for free onto your computer from our link that we can provide here in the chat. Izabela, I don't know if you can put that link in. I don't know if you have. Oh, yes, she did. She has. Yeah, so there you go. This will take you to our server, and you'll be able to check things out. Okay. Now we're going to go to another place that I really like, while we can, before the moon comes up. And that is going to be another galaxy that is a favorite of ours. It's fast becoming a favorite. And this is Messier 101. Okay. And Messier 101 has got a lot of really cool features in it, and that we'll see in a minute here. Okay, first things first, we're going to go back down to our 1 second exposure. Welcome back, Daryl.
Thank you.
Now we're going to go maximize, get our finder view here, and come back to fill our frame out in the whole view like that. There's our whole frame. Okay. This dark center is a correction frame that we use. It's called a flat field correction. It basically, when the sensor takes a picture on these cameras, the center is brighter. So this is automatically subtracted from the photos. Okay, not the live view, the photos. And it will make things all even across here. But in live view, you just have to suffer a dark center when this happens, because the live view it doesn't do that.
Is this still 4647 and M60?
Yes, I'm about to go to M101.
Yeah.
I already saved it and
Okay. Did
Yeah,
you
what were you
mention
saying?
the Type 1A supernovas standard candle while I was gone?
no, I didn't go through the whole standard candle thing with this.
Okay.
We could.
Well, since we're leaving, we'll save it for another time.
Okay. Either way, what Daryl's referring to is that when we see certain types of supernovae and other events in the sky, sometimes because they all happen the same way and they all happen to be the same brightness, we can use them to figure out how far away they are. And that's because when we look in the sky, these stars all have a brightness as it appears to our eye or our telescopes, and they also have a brightness that can be standardized. In other words, how bright would this star be if it was brought just 10 parsecs away? That is 30 light years away or so. And if we were to look at that star, it'll be brighter probably, or it might be fainter. It depends how close it is. And knowing the difference between those values, we can actually get distances. It's called the distance modulus. I can go through that with you at some other point. I know I'm rushing it right now, but look at this Pinwheel Galaxy. Who wants to rush things when you got this going on? So what I'm going to do is, this one is going to be a little longer. We're going to go 35 seconds on this. And we're going to get out of our hybrid finder mode and go into our stack. Here we go. Oh, I feel like we're going to space. This is great. This is another face-on spiral galaxy. It is Measure 101, different from Measure 100 that we saw before. And here comes the first one. Oh my, look at that. Gotta correct the color, but that's it. Look at that, guys. Isn't that beautiful? Wow. Looks almost like M100, right? The one we just saw.
Very much so.
I'm gonna move our black level over just to kind of increase the contrast. Look at that. Now you notice
Also,
this modeling, that's noise that'll go away as we stack. Go ahead, Daryl.
Go ahead.
No, you were gonna say, you said also, and
Oh, well, just on the comment you made a moment ago, this one also has a kink in the arm over on the left side, just like M100 did.
It says sharp bend right there and then right there. Isn't that weird? If you're drawing this as a picture, you'd be told that's supposed to be more gentle. Well, then again, nature proves us wrong, right, guys? Look how pretty. Let's zoom in on this. Oh my.
Darn, that's just three stacked images, too.
It's beautiful.
It is.
Wow. And the music is majestic, which is exactly what this galaxy evokes. Hey, Cosmic Ray, and Dean Bostador, and JSCO, how are you guys? Wow.
It's another showcase object.
It is.
Amazing how well that looks already with just 4 exposures.
I know. Look at that. Oh, if you look what the telescope is, it's literally almost straight up, pointing a little bit backwards. Lots of detail visible, guys. This is live astronomy, too. This is all live. You're seeing this galaxy with its many potential billions of civilizations in there, or hundreds of millions of civilizations, possibly. You're seeing it live. You're looking at them, and hey, guess what? They might be looking back at you. Wow. Really pretty. This was worth going to.
Tara says it looks off center a bit. It is, Tara. It has. Well, it looks like most of the mass is over right of center, but some of that is because of that crook in the arm on the left side. Tara, it's the galaxy has interacted with another galaxy, distorting it. Quite possibly that little fuzzy one over there at about 9 o'clock or 9:30 to the upper left.
That one there.
Yeah.
Oh, you're seeing a snapshot in time. Yeah. Thanks, Sandy boy. I'm glad you like it. This is just something else, man. People know what it is. We can get rid of this for now. This noise will go away the more we stack. We've only got 8 stacked. Hey Woody Rester, how you doing? I'm glad you're here, man. Thanks for coming. It's all free, Woody. It's all free.
And we've noted before too, one big OB association over there at about 9:30, and another one at about 8:30, and another one at about 5 or 5:30 or 4:30.
Yeah, right here.
Yeah.
Yeah, and what an OB association is, guys, is the hottest, youngest stars in the universe are O stars. They tend to be massive. They tend to give off most of their energy in the ultraviolet. The O stars do. And their color is decidedly blue. Okay, because blue is the hottest temperature you get. Okay? And so when we look at these areas in this galaxy, you can see a number of things. Like right here, you see this little chain of what looks like reddish areas here. You might think those are stars, but actually they're vast stellar nurseries in this galaxy, most likely. And then you see these chains of bright bluish green stars. Well, there's no green stars, so that's probably a blue color, and we would need to color correct to better illustrate that. So let me color correct that and see if it comes in better. Yeah, there we go. So now with it color corrected, you can actually see these are actually blue areas. So these are very, very hot young stars in the spiral arms, because that's where these young stars form, is in the spiral arms. My gosh, I'm just beside myself with this image. It's beautiful. It is a beautiful galaxy.
It is.
We're actually at higher than our threshold. We're not at 100%. Okay, now we are. This is the full native resolution of our sensor right now. We could go to 800%, but that's just, we see pixels. But let's just zoom in just to show you what I'm talking about. So we can go way in and move inside this galaxy here, but we see noise and pixelization. Again, much of that will go away as we stack more, because that's random noise that will go away. This is just, I gotta say, it's stunning. Stunning.
It is that.
It is.
And I think we've noted this before, but again, at about 9:30 from the nucleus of the galaxy, farther out from the spiral arm on the left, there's a object with a greenish tint to it.
Yeah, that's either a. Are you talking about this right here?
To the left of that, lower left of that one. But that one
This one?
too. I mean, that's greenish. That one.
Yeah. And we also have this galaxy here, which is probably the one that maybe it was interacting with. We'd have to check.
Yeah.
Look at this galaxy. Wow. Yes, these greenish areas, by the way, guys, what I think Daryl is going for, could be areas where there were previous supernovas in this galaxy, like this one maybe. Or if the color still has to be corrected more, maybe those are more OB associations, which were the hot O type and B type stars. Now, the way stars are classified is by temperature, primarily. So it starts with O and goes B, A, F, G, K, M. Okay? And that OB, those are hot and blue. A is white. F is yellowish white. G is yellowish. K is orange. M is red. An M star is like this one right here. Okay, this guy right here is probably an M star in the foreground, in our foreground here. It's in our galaxy. Every star you see in this image is in our galaxy, and we're looking through our galaxy. Oh, zingo! There goes a Starlink satellite. Every star you see in this galaxy is too small to be seen as an individual star. So if you see a star superimposed over this, a star, that's in our galaxy. That's up here, and we're seeing the galaxy through them. Okay, yeah. So that's how that works.
Some of those might be globular clusters in the other galaxy, though.
Yeah, possibly. And like this chain here, this is following the curvature of the spiral arm. I think this is, for instance, a nice sequence of stellar nurseries. And
H2 region.
Globular clusters. Yeah, stellar nurseries. Yep. Yeah, H2 regions, hydrogen alpha regions. I mean, we go by many names. Wow. This satellite trail only shows up on that one previous image. So as time goes on, it's going to get subdued over time. And look at this, Daryl. This is just beautiful.
Oh, yeah.
Look at that. Oh. You can see some really interesting knots in here. This area right here, we can actually clearly see that there's a knot right in here of bright, hot young stars, stellar nurseries in here, the H2 regions as they're called, yes, and many more throughout this galaxy. This is just beautiful. The time out there is 9:24. We're probably already getting brightening on the horizon due to the moon.
Yeah.
And to see that, let's try something. Let's start up the all-sky camera, and we're going to take and do a preview shot. We're going to take one image, and it's a 15-second shot here, and we're going to check out our sky right now. I bet you we'll have some glow. Okay, well, not that bad. But these are the lights of Phoenix right here, and we're gonna actually have some moon glow as well, because that's the east side. So it's adding to the moon glow, or the moon glow is adding to the lights of Phoenix. This doesn't show to your eye. You can't see this with your eye. It's pitch black out there. Okay, so only a sensitive camera can show this glow here. But as the moon rises, it's going to blow out everything. All right, but that's just to show you what's going on. All right, let's minimize that and come back to our stunning view here. Curtis Horn is here. How you doing, Curtis? What's happening? This is Measure 101, Curtis. Isn't this something? It is just beautiful. I'm zoomed in too. I'm at 114%. I'll back out to like 75%. And now we can actually, let me reduce some of the noise a little bit.
You might notice some resemblance to M100, as I think you may have mentioned earlier,
Yeah.
Mark.
Yep.
We're seeing M101 here. This is the Pinwheel Galaxy. We're seeing it much closer than we did M100. This one's about 20 million light years away. And when we saw M100, well, it's in the Virgo cluster, and the Virgo cluster is 50, 60, 70, 80 million light years away, so it's much farther.
Yeah.
If we saw M100 at the same distance, it might look much the same. This is also quite a bit larger galaxy than the Milky Way is.
Yeah. So we go to our planetarium view here. This galaxy is given as a distance of 20 million light years, it looks like. So that's possibly going to, be the reason why we see so much more detail in here. What a beautiful galaxy. This is live astronomy, folks. This is all live. Happening right before your eyes. Wow. It's just getting better and better. We're up to 24 stacked. I'm going to keep going.
Sure.
I'm actually going to do a safety here. I'm going to save now. No, I'm not. I'm going to actually change his name first. This is M101 Pinwheel Galaxy. Okay. Alright, now I'm going to do a safety. Because once the moon starts coming up, it's going to kind of ruin the shot. So I'm going to take one now and do a save exactly as seen. And these will be our safeties. Alright. Fantastic. Yes, this is Sharp Cap, as Curtis says. Hey Curtis, if you got anything you want to plug, please put it in the chat here, okay? We'll promote you. You've been a good help to us and a good friend of the Sky Tour family. Dimensional Legend, it's not a black hole. Well, I know you got this thing about black holes tonight, but this galaxy may have a supermassive black hole at its core. In fact, most galaxies may. That's part of what we're doing here, is trying to figure out as astronomers whether every galaxy has one. We suspect it's possible, and we suspect that they are the seed object to bring a lot of material together. Hi there, Paul Goodry. How are you? Yeah, this telescope belongs to our Sky Tour livestream organization that we created. So yeah, it belongs to us. For Sky Tour livestream, yeah. And I have to say, Sky Tour livestream, I'd say about 3 years ago, stopped being me and started being an us. The other people in Sky Tour livestream are Marianne Robb, who's here in the chat, and Tara Diulis, who is also here in the chat. Marianne is our project treasurer, and Tara is our project secretary. And we just can't get enough of views like this. So I can't, No, you're welcome, Paul. Paul says, that's cool, thanks for this, love it. Hey, look at this galaxy. I mean, look at the detail that's coming out in this, huh? Wow. Look at that, Daryl. I mean, this is really, really stunning.
Oh, yeah.
Let me try something here. Come back in here. I'm going to go to the enhancement tab, and I'm going to increase the radius of our unsharp masking. We're going to try and I have it 1. I'm going to go 1.5. Okay. Now you'll notice, maybe you don't, but you'll notice there's sharper details now and all these little details in here. And look at this little beautiful subtle wave in here. This is gorgeous. It's beautiful subtle dark nebula in there. Actually, that's really cool stuff. C&D Boy says, if Mark misbehaves, Marianne will tase him for us. Ah! I don't want that to happen. Okay, the truth is, guys, I've never been tased in my life. There you go. There's the truth. And the reason they say that is because Marianne is a police officer. Our observatory you see here over my head is on protected property out in the Sonora Desert. You can't get to it without special permissions. So it is quite a bit of a hassle for me to have to go out there and fix something. But you know what? It's the right place for this building. It really is. Marianne, you can just be quiet right now. She says, haha, you got that right, C&D Boy. No. He doesn't have that right. Okay, we're up to 32 stacked. I think we're good. I'm going to pause this now. And we have M101 Pinwheel Galaxy. Save it. Oh, Daryl, this came out beautiful.
It did. It's a beautiful picture.
Yeah, really, really pretty. All right, well, let's go back and, well, first of all, let me come in here, go back to our histogram, that is our data, and I want to actually try and bring this dark level just a little further in, not by much. Oh yeah, look at that. Wow. And then let's come back out and fill the frame. There we go. Look at that. Wow. That is pretty. Remember that satellite trail that went through? It's all but gone. Told you. Told you. Really pretty. Okay. Hello, Renee Cruz. No, I'm not daring you to tase me, Marianne. You just keep your mouth shut on that side of the world. Okay. And last but not least, we'll do one more. And then save the ping file again. Go ahead.
Interesting when you zoomed out like that, how many more galaxies you can see in the field. There's that one biggish one down there. Yeah. I would wonder if that might have been the one that M101 interacted with.
Yeah, maybe. But it's amazing to think of how much life we're actually looking at right now and not even knowing it. That just makes me crazy. I love it. Absolutely love it. You notice this bright area here with the dark in the middle. In the normal case where the flat field correction is working properly, this would all be even. But because we have that coming moonlight, the flat field correction is being thrown off. But it's fine. It's fine. It can all be corrected yet again. Alright, we're going to clear this now. I don't want to, but I have to. Goodbye, 101. We'll see you again. What a beauty you are. Okay, and let's go back to our 1 second. And do our beautiful instantaneous view of our, sky. Do our hypered view of the sky. Wow, that's really pretty. Okay. So let's see what else we can look at now. We're actually right near Mizar. And so that means that we are also near another galaxy we could see. Which we'll go to. Why not? If this one's coming out, maybe this one will look even better too.
M51.
Yeah, we're gonna go to Alcade here as our waypoint star, I bet you. So you're gonna watch the crosshair, probably go right to that. Although it did go to Mizar one night, but I think it's going to Alcade tonight. Okay, Alcade is going to be our waypoint star. And it's going to put Alcade in the center of our view. Right? And the center of our view. Alright, it's going to move it. As long as we're in that bigger circle, we're good. Alright. And then, once centered up, like that, pow, we're going to head off. And we're going to go to the Whirlpool Galaxy, which you'll see. And it should be coming right here, and there it is. It's smaller in apparent size in the sky than Measure 101. And its distance is 23 million light years. Okay, so there it is. Alright, so now what we're going to do is come back in here and let's have some fun with this one. Whoa, good thing we didn't take a picture there. That Starlink satellite would have ruined it. Okay, I keep saying Starlink. I think they're all Starlinks because that's pretty much all we're seeing now. Alright, we're going to do a 35-second shot of this as well because 35 seconds seems to be working well. But first, I'm going to get this back here. Just do this for a second. There we go. And I'm also going to go to our Starlink status, and you'll see in a sec what I'm doing. I'm going to set our auto guider properly. Okay. So I'm just setting this parameter here.
Interesting to consider. M51 is 23 million light years away, and M100 is 20 or so million light years away. That they're comparable distance. That M51 is quite a bit smaller than.
Yeah.
Just plain smaller than M101.
It is. Okay, and now we're going to come up. And this is one more thing too, which I may not have mentioned before, but I will. Let me just bring this up a little. Okay. Bring this over a little. Okay. All right. So what I'm getting at is we're going to go up to our status here. And when I hit enter now, you'll see numbers. These show us we're actively guiding on this right now. Now, right now we also have the moon coming up pretty soon. It actually should be right on the horizon, but we're going to try and get away with one more shot here. So let's do that. Let's do a 35-second photo and stack it and see if we can pull off the Whirlpool Nebula. There's the Whirlpool Galaxy. Alright. Hey Donald Kunzer, how are you?
I see two different numbers for distance. One says 23, which I think is the same as what you said. And another one says it's 31 million light years away. So it would be about half again as far away as M101.
And it's pretty bright. So let's go into our stack and drag this over a little more. Thanks for color correct too. Alright. And let's do a process. There we go. Wow. Ooh, doggy, that is looking really good. Okay, and now let's zoom in a little bit and see how we're doing. Wow. Okay. I got one thing I have to do. We're going to get rid of this stack right now and do something else immediately. And that is, we're going to do another focus round because I forgot to put the temperature compensation on and I need to do that. So to do that first, I'm going to get my focus back. So we're going to go into Tools and go into the Focus and do the full width half maximum focusing system and scan in.
Oh, your cooling wasn't on?
No, cooling is on. It's at -10. But the temperature compensation wasn't on for the focuser, so the focuser just stayed still.
I understand.
As it cools down, guys, what happens is the telescope focus will change, and temperature compensation is something I worked out several months ago actually, where I noted the focus change and how many steps in focus would change with the lowering of the temperature, and you work out a steps per degree parameter, and you put that in. When you put that in, then the focus will follow the temperature changes. All right, so when we come back into our system here, you can now see it's found its focal, its central focus point. There we go. And it may abort because it doesn't need to do any more, and it did. Okay, so now we're going to say best focus position. What's neat is Robin, the guy that wrote this program, he's been taking suggestions. I gave him some suggestions for the program, and he's actually included them. One of them is this temperature here. The temperature out in the building right now is 29.81. I get to see it now on the screen. He had the data, but he didn't show it. The other one is changing this from to best focus from another name he had, which I forget. Okay, good. Let's see if we can pull this one off. Ready? We're going to get rid of this guy. We have our focus done. And now let's see what happens here. Okay. All right. Let's quickly go back to 35 seconds here and try and do this. And we're going to get rid of our hypered view. And go back into our live stack and clear it of the previous one. You'll notice that actually when it comes in, it's going to be much more sharply focused. Yes?
Izabela was pointing me toward a question Cosmic Ray has. Where could he find info on the hardware and software in use? I would leave that to you to answer since it belongs to you.
Oh, that's okay. All right, yeah, this, as Curtis mentioned to you, that's a better shot. Look at that, more clear. As Curtis mentioned, this program here is called SharpCap. And I'm using the professional version, and this is a telescope connection system, but we don't need this. You could use this to connect to your telescope. This is Stellarium, which is free, and you see the STLS. That's where our telescope is currently pointing in our view. All right, so basically it's here. And if we come back, it may, I mean, it looks like, let's pop out of this just to make sure I'm not going to give it something wrong. Alright, so we come out here. Okay, and it's just above center. So what I'm going to do is...
Yeah, I've noticed Stellarium drifts a little bit. Your pointer over time. You'll sync on it and then you'll go back later and it'll be off a little bit.
That's fine. It's fair enough. It's right. I'm gonna set it up now. But you got to understand that we're also drifting because of the fact that we're actually we're drifting because of the fact that we are now looking way up north, and so this will have to happen from time to time. Look at that. Notice these little guys, folks. There's some additional stuff off of here, and you'll also notice other galaxies in this view as well. Even looking up into Canis Venatici and Ursa Major, you're still gonna find galaxies up there that are just very prevalent. There we go. That's kind of better.
If I could refine one thing I was talking about earlier, M51 is 76,000 light years across, compared to the Milky Way being about 100,000. And when we saw M101, it is 170,000 light years across. So M101 is over twice the diameter, the true diameter of M51.
Yeah.
Yeah, still are both grand design spirals.
Oh yeah. We've been learning a lot about spiral structure in galaxies, folks, and one of the things that we've learned is that galaxies may end up having their spiral structure induced in them. And Messier 51, this one, is actually one such galaxy. We think that Messier 51 has had its spiral structure induced by this galaxy that's in collision with it. So these two are literally orbiting each other. You'll notice this part here of the galaxy. This is the galaxy that is colliding with it. This part of the galaxy right here is a spiral arm from this galaxy. And if you look at me down lower left right now, this is what we're seeing, right? We're seeing this spiral structure with that galaxy at the end of it. But if we turned it on its side and saw it from the side, it would look like this. Okay, you see that? It would look like that. It looks like this. Because this galaxy here, this one right here, is actually further away. And further away. And so this galaxy's spiral arm is being warped down toward it. So it actually's got a warp in it. And that's something that's really interesting. We got to remember, it's a 3D universe. Okay? It's a 3D universe. And we're seeing that in full effect here. Oh my gosh, that's beautiful.
Cosmic asks, is there a URL that gives info on hardware and software in use? Do you have your specifications anywhere?
Oh, on our server, you can see the images I took of the hardware, but you can also ask me any questions you want. If you toss a comment into this, I'll respond to you and we can start talking. I'd be happy to share with you how we're doing this. I'm using a remote connection product, which you can buy. You've got, the PC connection products that you can get. The one I'm using is remote PC. You can use remote desktop to get to the computer. I'm actually using the computer in the building. If you turned on the monitor in the building, you'd see this screen, these screens right now. All right, so I'm actually using them like I'm sitting in front of them, and that actually is cheap. And Sharp Cap is cheap relatively. This product here was cheap. Stellarium is cheap. The program to show the cameras and the cameras, well, overall with the telescope that you see there and the building, we're looking at around $15,000 of commitment. And that came out of the pockets of the people that wanted to see this all happen, including me, including Marianne, including Tara, including people that donated in the GoFundMe. And this entire telescope, this entire organization has started as a GoFundMe, right? So we've not had to put money of our own in. We're actually doing the GoFundMe. So this is why I'm so zealous about making sure that I show you guys some cool things and spend the time to do it. It's almost 1 a.m. here in Connecticut, but I'm still doing this because I figure for those of you that have donated and put your money on the line to help us, you got to get something for that. I'm absolutely committed to that, and that's never going to change. You guys deserve the best, and I think, as I said, science is for everybody. The image sensor I'm using is the ASI 294MC Pro by ZWO Cosmic Ray. It's actually the finest camera, I think, for doing this kind of work, to be honest. Its pixel size is perfect. Everything about it is perfect. Sensitivity is good. If you notice over here in my in the sharp cap, the gain could be 0 to like 500, 0 to 600, and I'm going to 250. I'm not even going up higher, and look what we're getting. If I went higher, we'd get more noise. Okay, so 250. I was using 350 for a while, but 250 seems to be working just fine. You know. Hey, Forbidden Knowledge. Yeah, hey, Forbidden Knowledge. Thank you for coming out here. I'm so glad to have you with us. Grape Soda, welcome back. I'm glad you made it. Look at this, man. We're here with the Whirlpool Galaxy right now.
I'm always intrigued by between the two spiral arms to the left side of the nucleus.
Yes.
Up at about 9:30 or 10 o'clock.
Sorry about that. Yeah.
You see, but yeah, exactly right there. Between the two arms, there's that large, lightish, kind of bluish patch there.
Right there.
Yes.
Yeah, it looks like a large OB association. That could have been, that is, O stars and B stars in large clusters, and that could be due to the fact that in this interaction, when the arms are pulled and material is shoved around, there's compression, and a burst of star formation could have started. And it's neat that to think that this could have been created by a galactic collision, galactic interaction like we're seeing here. And this is very possible. Let's do a color balance again. Alright, and let's actually just darken up our sky a little bit. Let's put that black level. See, technically you can bring that black level right to about here. Right at the beginning, just right at the peak. Yeah, there we go. Yeah, there we are. And now you can actually see some of this additional stuff out here. See all that? Let me soften that noise a little bit. Here we go, ready? Soften the noise. There we go. Now let's look back at this. You can see these beautiful swirls, sweeps in here.
Actually, several OB associations, I guess, on the upper side of the spiral arm.
Yeah.
Just below the satellite galaxy. There's one at about 1:30. There's that one big one at about 10 or 10:30.
Yeah, got one out here.
And then that one right there that's the one I was talking about a minute ago. It's
one?
actually at a little bit to the right.
Oh, this one here?
Right there, yeah.
Yeah, yeah.
It's actually in between the two spiral arms.
Yeah, we got one here. We got a large collection of bright stars here, but that's not OB. That's probably just some... it's in the thick of the stars. We got some bluish cast here. That's probably that. We see some red. Okay, you see these beautiful convolutions of the dark nebula in here. There's dark lanes in this galaxy mixed with red. Those are those beautiful stellar nurseries mixed with the dark nebula in this distant galaxy, all those millions of light years away. And you're seeing it as it was millions of years ago. And Tara says, so dramatic. It really is. Sensor interface is USB cosmic ray, yes, but there are supplementary power supplies. Because if you notice down here at the bottom, this sensor is running at minus 10 Celsius. So we're actually 10 degrees below 0 Celsius. It's a super cooled sensor. I could go even colder, but 10 Celsius, negative 10 is good for this. And we're also running an F8 system at F2, by the way. So we actually have an additional lens on the front called the Hyperstar, which is actually, it's the only one on the world actually right now. It's the only Meade LX 600 with a Hyperstar on the planet. It's a prototype. Starizona down in Tucson, Arizona has produced this, and they made it for us and engineered special adapters for this. It's really cool. Hey Dead Sun Prime, how are you? Oh, he's talking about, yeah, that he says he won't live long enough to see it, but the heat death really makes him sad. Well, you know what? What is the heat death option? Heat death option is where all of the warm objects in the solar system have lost their heat now, or in the universe, I mean, have lost their heat. So how is that possible? Well, you can imagine that over time, and eventually what will happen is that the last star will have formed, and then the last star will have died. And when it does, the universe is going to start cooling. Like we saw with the supernova. That supernova was actually very, very hot initially, and then it became cooler as we watched it over time. Well, the same thing's going to happen with the universe. It's going to start cooling, and when it does, next thing you know, all the atoms that were previously hot are going to be cooling off, and so nothing else will be left. There won't be any more stars to see because there'll be no light being generated by anything. So when they say heat death, it doesn't mean death by heat. It means the universe will die as it gives off the last of its heat, and that's the heat death syndrome and scenario for the death of the universe. It's one of them.
Also known as entropy.
Yeah. Forbidden Knowledge says he lives in northern Arizona. The skies are so amazing. If I had a telescope, you would see so much. Yes, you would. Where in northern Arizona? Are you up by Grand Canyon? Are you up in the Gallup region? I mean, where are you? Because we are actually out in the Sonoran Desert, south of Wickenburg, west of Phoenix. We're on 20 miles of dirt roads after we leave the regular road. Golden Valley, okay. Beautiful area. Yeah, by Kingman, sure. I drove through there. I came from Vegas through there at one point. I do a lot of talks around the world, Forbidden, and I'll be in Roswell actually in just a couple weeks. I'm doing a talk there, and then I'll be in Denver doing a talk there. Then I'll be in Phoenix for a week out here at the observatory working on maintenance. Hi, Gabriella. Gabriella Basso is with us from the UK. This beautiful object we're looking at, Gabriella, is called the Whirlpool Galaxy. The Whirlpool Galaxy is not this one. Hold on. The Whirlpool Galaxy is called Messier 51, otherwise known as M51, and it's a beautiful galaxy that is interacting with another. That other galaxy is this one right here. And as I mentioned earlier, if you saw them from the side, you would see that that round one is actually down lower, further away, and it's bending the spiral arms of Messier 51, which you can see right here. That's actually the bend reaching out and bending down. Really cool. JSCO 77, Mark, can you share a little of your topic for Roswell? Yeah, actually, I'm going to be talking about the way interstellar travel could actually be made possible by the use of special particles generated by your ship. Let's look at the way UFOs are shaped. They're shaped like round objects. That's because I think they're particle accelerators. And they're generating possibly these very, very massive particles known as KK gravitons or Kaluza-Klein gravitons. What's that mean? It means that they generate particles that tend to suck the UFO, the object, the spacecraft, out of our 4 dimensions and pull it into a 5th dimension known as the bulk. And from there, distances are shortened, time is slowed down, and you can actually then punch back in at a different time, at a different location, fairly, well, I should say not easily, but fairly straightforwardly. That's how it supposedly works. And that's actually part of string theory called Randall-Sundrum 1 theory. It's an amazing it's amazing to think of how a spacecraft can travel in the universe without actually traveling through the intervening universe around it. But that's exactly what we're talking about. That's exactly what we're talking about. So, it's even too bright now. Let me actually lower the brightness of the core. Look at that. Now that's too low, but you can see this beautiful detail in here. Look at all that. That's so complex. Outstanding. Wow. So what I'm going to talk about actually is I'm going to talk about how that can work and how it relates to our 4 elementary forces that we have, right? We have the strong force, the strong nuclear force, the weak nuclear force. We have the electromagnetic force, and we have the gravitational force. And we know how the electromagnetic force is carried. It's carried by the photon. We know how the strong and weak force. The weak force is carried by what are called W and Z bosons, and the strong force is carried by gluons. Inside protons and inside the nuclei, and protons are held together. They want to repel each other, right? They're positive charges. They want to repel. But when you look at the nature of how powerful these forces are, they can hold them together. So that's how that all works. But that's just a little bit about what I'm going to talk about. It's a little more orderly because it's much more orderly, actually. What do you think of this, Daryl? Look at that. I think this is better than what we've had before.
Comparable at least.
Yeah, look at that beautiful extra stuff. That what we're seeing, there's extra gas and dust and stars being dragged out and dragged to a distance away by the gravitational interaction of these 2 galaxies.
Well, if looking at the left side again, down in the body of the main galaxy on the outer left-hand arm, I see a dark lane.
Right there.
And it gets pinched right where that blue area in between the 2 spiral arms is.
This here?
And then higher up. And then, yes.
Okay.
It gets pinched and then it widens up again, and it looks like that dark lane goes all the way up into the satellite galaxy.
Yeah, which makes me wonder whether the dark lane belonged in the satellite galaxy to begin with, and the more massive galaxy here is literally ripping it away from the satellite galaxy. I'd love to know how all that works.
Yeah, or vice versa.
Crazy. Yeah. Yeah. Now, Forbidden Knowledge is saying, "Wow, just looking at the moon tonight." Yeah, that's what we're trying to avoid. So, what I'm going to do is I'm going to just I already saved that like that. Okay, so we're going to save the Whirlpool Galaxy here, and then save it exactly as seen, and we'll continue to take a few more exposures. But we're going to quickly have moonlight encroaching.
Yeah. I actually stepped outside for a moment for a quick look at the moon.
Okay.
It rose in the southeast. Actually, I forget 9:20 or something like that here.
Okay.
But it's been skirting the horizon because the moon runs when the moon is near full in the summertime, it runs down low in the south.
Yeah.
So it's kind of been hugging the horizon, but is just now breaking through the trees over to my southeast.
Okay.
Very pretty view.
Well, not to an astronomer.
Sure it is.
Not when you're looking at galaxies, but yeah, you're right. It is pretty. I can appreciate the beauty of the moon.
I enjoyed watching moon rises and moonsets before I ever got my first telescope.
Oh, sure. I did too. In fact, I studied craters in the moon and all that stuff for years. You know, then when I was teaching astronomy, I would actually, have people look at photographs of the moon and have them calculate the depths of the craters based on the shadow angles, elevation of the sun, curvature of the moon. And once you give them the equations, then it's just a matter of applying them, because some of them can't understand the geometry and how the spherical geometry is going to work, But you just get it across to them conceptually and they can do it. It's really pretty. Sometimes to see details, you move the thing around. And as you notice, you can see that there's this faint little tail coming off of this, and lots of detail. I think I want to zoom in on this. Let me remove the name here for now.
A lot of faint stuff on the bottom down at 6 o'clock too.
Yeah, huh?
Way out.
Okay, this is 175%. Oh, look at that. Wow. Let's move this around. Yeah, look at this big fan. This big giant fan of material here.
Yep. M51 is a safer galaxy too. It has an active nucleus.
Yeah. Safer galaxy, SEYFERT, guys. That's a galaxy who, as Daryl said, nucleus is active, is doing things. It's possibly shooting radio beams out, and it's just amazing. I just wanted to define it for them. While we're here, let's try adding a little extra. See, we're at 1.5 for the unsharp mask, 1.5 pixel range. Let's go to 2. Okay, look at that. So now at 2, now we start to see little halos appearing around the stars, so you know that 2 is too much.
If you look at the right-hand spiral arm down at around 6 o'clock going up to toward 3 o'clock, several very distinct dark patches in there and blobs.
Yeah.
And then you get a little bit higher at about 3:30, and it's almost like some light bars going across
This guy.
between the inner and the outer spiral arm.
Like this.
Yes.
Yeah. That's pretty.
And you've got a dark patch between the inner and the outer arm up at about 11 to 12 o'clock or so also.
Here?
Yep, that, and then there's a very skinny, dark, distinct one on the outer part of that, just inside the outer arm there, right at 12 o'clock.
Oh, so you're talking about this here?
That too, yes.
Yeah. And then you got this right here.
Yes.
Crossing over to the other arm. Typically, this material, guys, should be aligned with the spiral arms, like it is here. See, this dark area is aligned with the spiral arm. But if you notice here, there's chaos here.
Yep.
It's been ripped apart from spiral arms. It should be in the spiral arms, but it's not. This spiral arm is split up. This is like dragged out interstellar dark nebula material that probably was dragged out by the collision between these two galaxies. And again, we're only seeing a snapshot in time.
And that spiral arm looks broken at about 10 o'clock.
It does, doesn't
Again,
it?
just to the inside of, there's that one dark patch and the blue patch in between the two spiral arms.
Yeah,
But there's a
it does.
discontinuity in the spiral arm right there at about 10 o'clock.
Yeah, you talking about this guy?
Just above that.
Are you talking about this? Where this
Uh,
OB association looks like it's being
just below that, yeah. It was
right
that
here.
dark area, yeah. That dark area, there's
Yeah.
like a discontinuity in the spiral arm there almost.
Yeah. If you look at this arm looks like it's been like relatively untouched. And then the one in is relatively untouched. And this one here, there's chaos ensues where this stuff with that, again, this dark stuff normally follows the spiral arms and it's in the spiral arms. But there's chaos here. This was ripped to pieces here by gravity. And this galaxy out here. Wow. Ah, that's just beautiful. Okay, we're gonna pause it now and save it because we've reached the limitation on the telescope for the moon for doing faint objects tonight, I believe. We've got moonlight infecting us right now, so we're gonna clear this. This is beautiful. This will be up on the server in just a few minutes. And Izabela has been wonderfully putting up all of our objects. Thank you, Izabela. Okay. Wow. Well, it's 1:13 in the morning here, and I am going to call it quits for tonight. I want to thank you guys for coming out. I think that it's been a lot of fun. You guys have been wonderful. All 75 of you that are watching, I hope you're enjoying it. And make sure you come back because we have a lot to see. Our summertime sky that's approaching, as soon as the moon starts going away, we may stay up longer and check out the early summertime sky. There's so much in the summertime sky that we look at, and Daryl and I have made it a point of trying to find these dark nebulae places, these absolutely dark, wonderful places in the night sky that are just phenomenal to look at. And we've managed to take the pictures of them quite nicely. They actually come out great. So we'll do that again too. Thank you so much, Izabela, for what you're doing with us there, putting our information out there for the live server. And guys, I hope that you have a good night. And Daryl, thank you once again for coming along for the ride.
Sure.
And we hope you guys will come back next time. It'll be quite a few times in the next few days. So we'll see you again, and you guys have a good night, all right? We'll see you later.
Good night.